All right, so you're welcome back. We are still solving systems by reducing matrices, but this time around we want to talk about systems we call homogeneous system and non-homogeneous system. Homogeneous and non-homogeneous. Okay, so if we have the system given system of equation like this, you might observe when we were in the previous videos, please, if you have not watched those ones, make sure you watch them. We are having an equation like this with a value at the right hand side. Okay, we're having a system of equation like this. So if I write this for example, 2x1 plus 3x2 plus x3 equals to 5. Then I have 3x1 minus s2 plus 3s3 equals to 6. Then I have x1 plus s2 minus s3 equals to 1. Okay, so this system, just like this one, this is a general form of it. This system is homogeneous when all these values are 0. When this is a 0, a 0, a 0. When all these values are 0, not bringing them to this side, no, they are 0. Okay, they are not being brought to the left hand side, they are 0. So that means a system like this is an homogeneous system. A system like this, okay. So a system like this is an homogeneous system when the value of the constant or the value at the right hand side, they are 0, they are all 0, or the constant value is 0. So that is an homogeneous system. Okay, but if they are not 0, then that is non-homogeneous system. So if, for example, this is 5, this is 6, this is 7, so this is a non-homogeneous system. A non-homogeneous system. Anytime you have a constant value included in the system of equation, then that is a non-homogeneous system. Okay. Or even at least one of them is not 0. This can be 0, this can be 0. For example, this is 0, this is 0, but this one is 0. At least one. If at least one is not 0 out of the constant, then it is still non-homogeneous. It is still non-homogeneous. So the system is a non-homogeneous if at least one of the BIs is not 0. At least one. At least one. So, but for it to be homogeneous system, all of them, all of the BIs must be 0 for it to be homogeneous system. Okay, please ensure that you understand. Okay, so now we have this for homogeneous system. Let A be the reduced coefficient matrix of a homogeneous system of m linear equations and n unknowns. Okay, so we have equations. For example, these are equations. Okay, how many unknowns do we have here? 3 unknowns. So we have 3 equations here, 3 equations, and then we have also 3 unknowns. Okay, sometimes we may have more than, okay, for example, let me write another one here. So we have 2x1 plus 3x2 minus s3 equals to 0. We are dealing with homogeneous system. X1 minus s3 equals to 0. Okay, so here we have 2 equations. Here we have 2 equations. We have 2 equations. But how many unknowns do we have there? 3 unknowns. Okay, 3 unknowns. And this is homogeneous because these are 0, 0. Okay, All right, so if A has exactly k unknown rows, okay, then k less than or equals to n, then k is less than or equals to n. So the number of the row should be less or equals to the number of the unknowns. Okay, don't forget this is m, which is equals to the equation, n, which is equals to the unknown. So the number of rows, it is either less or equal to the number of the unknowns of the variables. Okay, so we have these two situations. If it happened that the number of rows is less than the number of the unknowns, then we will have infinitely many solutions. So like in the previous example, where we have parameter values, two parameter family of solution, that is infinitely many solutions. Like the one we have only one parameter is also infinitely many solutions. So if the number of non-zero rows is less than the number of the unknowns, then we have infinitely many solutions. But if they are equal, then the solution is unique. The solution is unique. Okay, if they are equal, the solution is unique. Okay, you could also have it as a trivial solution also. So consequently, a homogeneous system of linear equations with fewer equations than unknowns has infinitely many solutions. So if you have equations less than unknowns, then we will have a case of infinitely many solutions. So anytime the equation is less than unknowns, like this one, then we have infinitely many solutions. Okay, please take note of that. So for example, determine whether these has a unique solution or infinitely many solutions. Unique solution or infinitely many solutions. Here, how many equations do we have? Two equations. How many unknowns do we have? 1, 2, 3. 3 unknowns. So since the number of equation is less than unknowns, number of equation is less than unknown, then we have infinitely many solutions. So there are two equations in this homogeneous system, and this number is less than the number of unknowns, which is 3, thus the statement above. Thus, by the statement above or previously, the system has infinitely many solutions. Please take note of that.